Alright, hi everyone. For today's video, we'll be looking at chapter 5, which is on the enzymes chapter. Before we begin, let's just do a bit of recap first. So in the previous topic, you learned about the three common types of nutrients. Do you still remember what are they? Okay, so the three common types of nutrients are your carbohydrates, your proteins, as well as your fats. Okay, so for your carbohydrates, there's a few types of them lah. Okay, so in terms of what smaller units are they made up of, your proteins are actually made up of your amino acids. Your carbohydrates are made up of your monosaccharides, and your fats are made up of your glycerol and fatty acids. Okay, I hope you still remember some of these. Now, you might recall that in your lower sec days, your teacher actually shared with you how can you break down these nutrients into smaller substances. So that's when you learn about some stuff that are called protease, amylase, and even a term such as lipase. Now, maybe some of you already forgot what are these terms, but it's alright. I just want to remind you that actually all these three things, right, they are what we call enzymes, right? And so this links back to today's lesson itself. Find enzymes in a lot of things. Okay, first of all, you can find it in your digestive system, right? And that's the most common one. So in your mouth, there's a certain type of enzyme, and in your stomach, there's a different kind. Okay, and of course, actually in your day-to-day use, right, the washing detergent, the laundry detergent that you all use at home, they also contains enzymes. So if you look closely at their label, right, you might see certain terms such as lipase, protease. So all these enzymes are actually able to help you remove away the stains that's on your shirts, right? That's why you use it for the washing detergent. So in this topic, right, there's actually 6 main things that we want to cover. First of all is exactly what is an enzyme. Okay, so let's first talk about the definition of an enzyme. Now in this video, right, all the words that you see that's in a different color are the blanks in your notes. Okay, so as we walk through this video, do fill in the notes as well. So before we can talk about enzymes, right, we need to first ask ourselves about this term, a catalyst. Now, catalyst refers to a substance that speeds up a chemical reaction without itself being chemically changed at the end of the reaction. This seems like a lot of big term, but if you look at it one at a time, you realize that number one, there's speed that we are talking about. So a catalyst must be able to speed up the reaction. Number two, at the end of everything, the catalyst must stay as it was at the start, so that it should not be any change at all. Why must we learn about catalyst? Because enzymes are actually proteins. Okay, they are actually proteins that act as a biological catalyst. Now we say biological because they are found in living organisms, and they help to speed up a chemical reaction without itself being chemically changed at the end of the reaction. So this is exactly the same as the definition that you saw just now, speeding up of a chemical reaction without itself being chemically changed, just that in the context of an enzyme, this is actually a protein. Now you might still recall that in the previous lesson on nutrients, you learned that protein looks like this. Right, they look like a ball of wire that's being coiled around itself to look like a 3D shape. Now, so this is one way that represent protein, but more commonly in your notes, you'll see that your enzyme actually looks like this. Right, it looks like a Lego block, like what I mentioned just now, but I would more often refer to it as like a jigsaw puzzle piece. Okay? So you see there's certain edges, so on and so forth, the shape of it. Right, and we'll talk about this later on. So later you see this image appearing over and over again, just remind yourself that this is an enzyme. So enzyme is a type of protein. Now having said that, since enzyme is a type of protein, we can actually test for the presence of enzyme using what we call the burette test. Now if you recall in your burette test, you actually use sodium hydroxide and you add in drop by drops of copper 2 sulfate solution. Now, how many of you still remember what we see if the protein is present, which means that in this case there's an enzyme, right? I hope that some of you still remember that if there is an enzyme, which is a protein, by doing a burette test you end up getting a violet or purple color of a solution. Okay, so that's what you should observe. Now in terms of an enzyme, right, what is interesting about them is when we name an enzyme, we actually need to look at what are the things that it acts on. So the substance that the enzyme acts on is what we call the substrate. Okay, and the name of the enzyme usually reflects the name of the substrate as well. But more importantly, more often than not, it ends with the three alphabets ASE, ACE. So let's take a look at some examples. So for instance, if an enzyme were to act on lactose, the name of the enzyme will be lactase, right? So you take the name of the substrate. So these are the substrates, and you take the name and you just change the last few alphabet and change it to ASE. Now, if the enzyme acts on sucrose, then the name of the enzyme will be sucrase, right? If it acts on lipids, the name will be lipase or lipase, right? And now if it acts on starch, the name of the enzyme should be, right? Some of you might be thinking of starchase, okay, but no, it's actually called amylase, right? So amylase is one of the unique enzyme that has a different name from what you expect it to be. So these are 4 common enzymes that you might come across: lactase from the word lactose, sucrase, lipase, as well as amylase. These are the usual way that we name an enzyme. Now, in terms of the reactions that an enzyme can catalyze, okay, we use the word catalyze to refer to how the enzyme acts on the substrate. Okay, the word catalyse is just a verb to describe how the enzyme can act on the substrate. Okay, so there's actually only 2 types of big groups of reactions that an enzyme can catalyze. Now, first of all is what we call a catabolic reaction. Now, a catabolic reaction means you break down a large complex molecule into simpler ones. Now, a very good examples will be your digestion. Right, digestion is when you have big molecules being broken down into smaller molecules so that your body can absorb. Right, so this is a type of catabolic reaction. Now, over here I have a diagram to show you how a catabolic reaction looks like. Okay, so for instance, if you think about it, and you look at this diagram, do you still recall which are the enzymes? Right, so the enzymes are the one that's in the green image over here. So these are the enzymes, and because this is the enzyme, the one that it acts on, which is the shape that is opposite of what it is called the substrate. Now, in a reaction, what happens is that the substrate will move forward the enzyme, and you actually feed onto the enzyme based on the shape. You might realize that the shape over here is actually very nicely fitted into the shape that you see over here. Right, and this is a particular feature of the enzyme. So when they come together, we actually call this an enzyme substrate complex. Now, because there's both an enzyme as well as a substrate. Right, so it's called an enzyme substrate complex. Now, in this complex itself, there will be a reaction, and this reaction, what actually happens is that the enzymes still stay as it is because enzymes are chemically unchanged at the end of the reaction. The substrate, however, actually went through a reaction to give you a products. So what is the change over here? What you realize is that the substrate actually went from a very big size molecule to 2 smaller molecules, and this is the characteristics of a catabolic reaction. Alright, so catabolic reaction is when you actually break down large molecules into simpler ones. Okay, let's take a look at an animation to see what it means. Right, so over here in this animation, right, I actually have this very big purple shape that's moving around. Okay, and this is the enzyme. If you look closely, you realize that enzyme has a shape that it serves as a spot whereby the substrate, which in this case is this long green string, attached to. And you realize that when this green string comes about, there was about 7 of the green circles. Then when it fits in, it actually breaks apart and remove one of the green circle. So if this thing goes on forever, you realize that from one long string, you can actually break it apart into many smaller green circles, right? And that's the idea about catabolic reaction, taking something big and breaking it apart. Now back to the notes. Some examples of your catabolic reaction will be like digestion, right? So you have large molecules like proteins, fats, and starch. Because they are too big, they cannot be absorbed into your body, they cannot pass through your partially permeable membrane. You have to break them apart before they can go into the blood. Okay? So the second type of reaction that enzymes can catalyze are what we call anabolic reaction. Now, anabolic reaction is a synthesis reaction, which means it forms or it makes larger molecules from simpler ones. So you can think of this as like if you take many monosaccharides, which is like this. If you take like maybe 1,000 of them, you join them all together, then you get 1,000 in one string. That is considered an anabolic reaction because you make a lot of smaller molecules, stick them together by the process, and you end up with a very long and large molecule. Now over here also have a diagram to show you what it means. So same thing, you have your enzymes, and you have two smaller substrates. They come together, they feed in to the enzyme, and they form this thing, which is what we call an enzyme substrate complex, right? So in this enzyme substrate complex, a reaction happens, then the product is formed. The product is now a larger molecule compared to the initial two substrate. The product leaves. So this is an anabolic reaction. Now, in terms of how it looks like in terms of animation, likewise over here, I have a purple enzyme. I have two smaller circles, one red, one blue. They are like the substrates, right? They are not connected together at all. But once the enzyme come about and they feed in to form the complex, the reaction happens and the blue and red circle gets joined together. This is what we call an anabolic reaction, whereby you feed two or more smaller molecules together to get a larger molecule. So just to re-emphasize again, imagine you have two smaller molecules. The presence of an enzyme, which is this green shape over here, by bringing these two smaller molecules together, you actually join them together. Now if you repeat this over and over again, you actually end up with a long structure, which is the idea of your anabolic reaction. Alright, so that's what we have talked about so far. What are enzymes and what are the types of reactions that an enzyme can catalyze. Alright, we'll pause over here before you proceed to the next video.